I do business intelligence out of San Diego Airport, and with me here is...
I'm Daria Rostovtsev. I'm a solutions engineer with Snowflake.
And we're here to talk to you about snow in San Diego. Anybody here from San Diego besides the people working with me? Cool. Anybody know when it was the last time that it snowed in San Diego? I'm going to leave you with tons of super useful data bits, seeing as how we are here, at this big data conference. 1967, which makes this like, a really historic event. It's also the first time somebody made the mistake of letting me up on a stage like this. So, but yeah, so I guess one more audience participation question. How many of you flew here? Okay, cool. So basically all of you all are going to be parts of this data story. When you're sitting on the runway, when you're, speed walking through the terminals, getting your Starbucks coffee and so forth and so on. We have sensors in the ceilings, that we track your throughput with LiDAR. We actually, we have sensors that track your cell phones as well. And obviously when you're picking up your rental cars and so forth and so on. So that's all super important operational efficiency data for us. Don't know what this is. And, this is us. We talked about that. But getting right into it. The interesting thing for us at San Diego is that our big claim to fame is that we are America's busiest single runway airport. I like to think that we're actually right up there in the world on that as well. The other two big airports in that dimension are Gatwick and Mumbai, but both of those actually have another runway, and neither one of them has a capacity constraint because they don't have a curfew. And as you can see from this beautiful visualization that I put together here, we do about 200,000 operations each year, process about 25 million passengers, and to the north of us we have Marines, to the east of us we have America's finest city, to the south of us is a whole bunch of water. And then to the west of us are the communities of Ocean Beach and Point Loma, which means that we have no room to expand. While a lot of you in this room probably have this wonderful opportunity being in the private sector. Oops, I think I just lost my mic. Can you all still hear me?
Yeah.
Okay, cool. Then I'll wait until, let's just leave it like this. This is easier. So, being in the private sector, you can either grow the share of the pie that you occupy, or you can probably grow the pie as a total. From this visual here, you can see we are not going to grow our pie, and the nice thing being the only regional airport in San Diego is that we eat the entire pie already. And then here from this, you can also see our capacity constraint is pretty high, so for each one of those hour blocks throughout the day, from the 6 to the 11 o'clock hour, you can see that we're already really reaching up pretty high to what our capacity is. And as I put in the subtitle there, just buying a second runway really wasn't the option for us. Now, I will say that at one point in time we did try to crowdsource crayons to get the territory through north of us from the Marines, but ultimately we fell short in that endeavor. So yeah, that was a bit of a shame. The nice thing about all of that though is he got the joke. As a business intelligence professional, in previous worlds that I lived in, car exhaust, Petco, watches, business intelligence very often was kind of it was a nice to have. It was cool for the business that we had it. We did nice reports for everybody, but it wasn't really an essential thing that the business needed to do. For us, seeing as how we can't grow our share of the pie and we can't grow the pie as a whole, the only way that we're going to be able to remain as an ongoing concern over the next, 5-10 years until I eventually retire, is by us better understanding the data. And that's where this now becomes the most fundamental, what I call a geospatial problem that you can have, because everything for us relates to the runway. If we don't understand what's going on our runway, we don't really understand anything else. So, not the runway, not the apron, not like you guys speed walking through the terminals, and not anybody picking up, the rental cars like on the land side or things that happen in our parking plaza. And this is another super useful bit of information you're going to learn here today. As we were trying to figure out how we're going to make sense of the information that we have for the runway, we learned about these signals called ADS-B data. Now, ADS-B, for anybody who wants to keep notes, stands for Automatic Dependent Surveillance Broadcast. And it's actually a really cool system that the aircraft now are all equipped with. It's basically, I think the genesis of it was collision avoidance. So sometimes you would have one aircraft coming this way, the other one going that way. Pilots at some point in time recognize they're on a collision course and then they bank in the same direction, and then they still end up having a collision, which obviously at altitude is not a good thing. So they came up with these ADS-B data, and basically what that consists of is just a whole bunch of latitude, longitude, velocity, vector, altitude, call sign, tons of super useful data. And so if you want to understand what's going on our runway, if the aircraft are giving us geopositional data, well, that helps immensely in doing that. However, this wouldn't be a business intelligence talk if we weren't going to be bemoaning the fact that the data is of course not going to be clear. And there's three examples. I'll mention the last one towards the end, because I've seen a tendency in these talks that people sneak out, and maybe I can keep one of the people that would have snuck out otherwise in their seat if I do it this way. But the first thing that we have is ADS-B jitters. And so what's happening here is that the ADS-B data is being sent to us to the 4th decimal of the latitude and longitude, which means that if we're measuring this at the equator and we're close enough to the equator where we don't care too much about the measurement differences, it means that that measurement is within an 11 meter or 30-foot radius of the points that we're recognizing there. Which, again, if you try to keep two aircraft from crashing into each other, that's probably a fairly healthy radius. But for our use cases, for example, we want to measure taxiway occupancy or taxiway utilization. Well, my aircraft keep bouncing in and out of that segment that I've defined as a taxiway. On the one day, my taxiway utilization may be 57%, and the next day it's 85% when we have exactly the same level of utilization across the airport. And if I tell that to my operations people, they are just not going to talk to me anymore, which would be very sad because they're really cool people. And then the other problem that we have is that sometimes pilots, in a way that I personally find to be very ironic, considering what they tell us about what we're supposed to do with our seatbelts, will actually turn off their ADS-B system way early. And so you'll see here, I'm just moving around, it's more fun. So you'll see here that this particular flight operation, clearly moved to one of those three gates, 32, 30, or 28. But because the pilot in this case turned off their system early, we have an attribution error. We won't really be able to figure out where did they get to. And that's the point in this talk where I'll turn it over to Daria, because having all of this magnificent data, we get about 650, 700,000 records of ADS-B data for the 5-mile radius around our airport. But that's where we needed a solution provider that could actually help us make sense of all of this geospatial data. So,
excellent, thank you. I'm a solutions engineer on the Snowflake public sector team, and we have been working with San Diego airports for about 2.5 years, two years as a customer, but before that we ran a competitive POC against some other vendors, and it became very clear, is what I'm hearing, is that Snowflake was really the best solution for their needs. This team is very small. It is a growing team. We have most of them here today. But yeah, the team ultimately is small. There is no capacity to maintain complex installations of really anything. And Snowflake's inherent ease of use and elasticity and connectedness to what really matters for airports has been a really game changer for San Diego. So we started working about 2 years ago. The original use case was really not this fancy stuff that you guys are about to see, but more of a traditional platform modernization, right? So the data was in a variety of places. The team needed to bring it all under the same roof so that you can then start on these more advanced use cases. Now, as you've already gathered from Andre's intro, the airport's data and the problems that they're facing is inherently geospatial, right? So you can't turn around without having to deal with geospatial data. Now, in Snowflake, we have been building out geospatial capabilities over a number of years. We were one of the first platforms to add geospatial data types, and we've just been growing more and more of the capabilities, adding geospatial functions, adding H3 support, Iceberg support in last year, and now with Coco, Cortex Code, now known as Coco officially, you can actually put all these capabilities together to build very advanced geospatial solutions that meet precisely your needs. Just to double click a little bit on geospatial capabilities in Snowflake, how many of you are already using geospatial data in Snowflake? Yeah, so a few. Okay, that's great. So we support native geospatial data types, the geography and geometry. Geographies for unprojected data, geometries for data that has some projection applied to it. We have support for fast and efficient geo-join, so joining on geospatial columns. We support geo-pruning. I'll talk a little bit about that as well. And in the Snowflake marketplace, there is a plethora of geospatial or geospatial-oriented data sets that are super useful for a variety of business needs. To zero in on a few capabilities a little bit more, Snowflake supports H3, which is the discrete global grid. So if you think of the Earth as a soccer ball that is subdivided into these hexagons, so H3 is essentially this collection of nested hexagons that makes it very, helps in a variety of ways. So if you translate your geographic coordinates to these hexagons at different levels of precision, it helps you bucket geospatial points. So ADS-B data that is flowing in out there, it's all discrete points. There's so many of them, it's really hard to do anything at scale with ADS-B data. That's where H3 is super useful. And H3 also is very useful for joining disparate geospatial data. For example, if you have vector data and raster data, H3 can be that Rosetta Stone, so to speak, where you can stamp both, or translate both into H3, and then you can start doing advanced joins and geospatial calculations at scale. Geo-pruning, I kind of mentioned it already. Geo-pruning is, if you are familiar with the term pruning in general in Snowflake, meaning that being able to eliminate the micro-partitions early on in the query, so you don't have to go through and scan them every time you're trying to find a specific data point. Snowflake somewhat recently added support for geo-pruning as well. So just like we keep statistics inside your micro-partitions on your numeric and character data, we also gather statistics on the geospatial extents that are covered in micro-partitions that contain geospatial data, and that makes eliminating or narrowing in on specific micro-partitions so much easier. And that is out of the box. You don't have to enable anything, it just happens. The same ease of use as we bring to the rest of the platform is present there with the geospatial data as well. Of course, if you are looking to speed up your geospatial drawings, filtering, and so on, it helps to have highly clustered on geospatial characteristics as well. And we have also recently hit an iceberg. So the future of data is really open data formats, table formats. This April, V3 of iceberg went into general availability, and it includes support for geometry, geography, geopruning, and all the great stuff that I was talking about. And last but not least, the geospatial marketplace. Who here has been perusing or is using geospatial or any really data from the Snowflake marketplace, data or apps? Yeah, a few. So maybe something to look into later. There's so much that you can gain from there. Tons of data sets, a lot of free sources of data that is either geospatial or can help with geospatial type of problems. One that I will call out specifically, Overture Maps, that is courtesy of our partner Carto. It's hosted by Carto, a free source that you can go and grab from the marketplace, but it's really a partnership between many contributors, and that is just an outstanding data set that contains 2.5 billion building footprints, 5 million administrative boundaries, 67 million, I'm reading here from the slide as you can see, of points of interest, so much useful data there. And all of these features come together and enable you to build solutions that, like the one that you're about to see in a couple of minutes, all of that comes together with Coco. This slide has not been updated since yesterday. Now Coco is officially called Coco, not Cortex Code anymore, if you heard the keynote. Coco understands geospatial data really well, and it also understands how to put it all together. So the solution that we are here presenting to you, it was built in collaboration between San Diego Airport's, our geospatial product team, and with the help of all the features and functions that I was just talking about, and a large part of it was really Coco that can help us put it all together very quickly. I would like to give a shout out to folks who couldn't be here, so the geospatial product manager who had a huge part and actually built the original version of the solution, Alexei Belov. He's in Germany, couldn't make it. And then the San Diego team here, Maggie and Justin are here, so maybe you guys can wave. So it really is a collaborative effort, and yeah, super happy to have Andre demo it in a second. But before we go into it, kind of high level, what is happening there? This solution leverages the freely available ADSB data that comes from an API, so we ingest it from the API. The Overture base maps is used for the airport footprint that you will see on the maps there. And this data is massaged, cleansed, transformed with the geospatial functions. There is the H3 stamping happening to produce analytic-ready tables that can then be visualized and put to use in the application that you will see. And this solution can be deployed with just a few commands using Coco. So that is the whole idea, that this really is an accelerator that now any airport can go and deploy for their needs. All the data that is used in the GitHub repository, that I will show you the link for that, later. It's all readily available, so you don't even need to bring any data yourself. But if you have data that you think is better, that you want to swap out, or like San Diego did, they took the original version of it and customized it using Cocoa, brought more of their data, more of their own use cases, and that is what we have the pleasure of showing you today.
Okay, well, let me see if I can figure this out. And it looks like, oh, there's my microphone. Cool.
There you go.
Okay, so before I go into the actual product demo, this is a post that Alexei, the aforementioned, put up a couple of hours ago. He apparently used that very system that we're talking about here to track our flight over here, which I feel somewhat queasy about. I guess we live in the surveillance state right now, so it is what it is. So to first demystify a little bit what we're talking about here. So here we have our airport's data, and again, this is like, I think...
Hang on, we can only see Alexei.
Oh.
You need to switch.
Okay, I was in presentation mode. Sorry about that. See, this is how I don't work in IT. Okay, cool. So now we can look at ADSB data. All right, so as I mentioned, for 6/1, we captured about 600,000 records. I don't know what day of the week that was. And then you can see here we have the flight, the aircraft type, the flight number, timestamps, coordinates, the vector that aircraft was moving in, the true heading, if it was broadcast like that, velocity, and so forth and so on. And I think what we're looking at here is a landing operation for an American Airlines flight, so we should see them eventually go down to a speed of 0. Yeah, there you go. So now they've stopped at their gate, which it's already somewhat useful data. But then we can very, very quickly, or we were so before I talk about any of this, actually I was not going to do this, but I want to give a quick shout out to Coco, because while Daria was talking, I was making sure that these things still worked, and we have daily capacity limits in place, and because like the neurotic person that I am, I kept refreshing it and making sure that everything still worked. I had actually exceeded our daily capacity limits, so I quickly messaged Coco saying, help me fix this, and in about 2 seconds I had the SQL command that allowed me to fix this. So I was going to go into this talk with we are the one talk that isn't going to talk about Coco, attitude, but even I have to bow to its superiority, I suppose. So what we're looking at here, as I mentioned, we are a very land-constrained airport, and we have very nice neighbors here in these two communities here, and we would want to be good neighbors for them. So what we're doing here is very simple, just taking all of the geospatial data for one particular Delta Airways flight operation and making sure that as they're departing our airport, they are not executing a turn before they get out of this particular polygon. I do not know who set these particular buoys up, but we know that if an aircraft executes a turn in that area, it ends up creating way more noise for all the people sitting underneath them. I'm not a physicist, but I guess somehow when you're just flying like this and both engines are aligned, that creates a certain noise profile. Once you go like this, it makes it way louder for everybody sitting underneath. The interesting thing, at least to me, about this story is that somewhere in this area allegedly lives a retired engineer who, in his ingenuity, is only outclassed by his pettiness. And so what he did is he got himself a Raspberry Pi board that he can use to press a button to send noise complaints to our airport, which is one of the reasons why we as an airport care very, very deeply about making sure that our airline partners stick to this particular agreement and don't execute an early turn. And you may imagine that if you work in our planning noise and environmental team, actually having a system that, again, this is not super complicated, convoluted math. You just take the headings of this aircraft. You make sure that that heading doesn't change by more than 15 degrees before it gets out of this particular geofence, and all of a sudden you know whether or not an aircraft operation is in compliance or is not in compliance. Overall, it's not a complicated thing, but just with a couple of very simple clicks, we were able to create something that already has super great business value. Where it becomes even more interesting is when you think about a run, like a single runway airport like ourselves, sometimes we end up with runway crossings. And I'm sure everybody here will appreciate that a runway crossing and a departure or landing operation happening at the same time are not generally a good idea. And so we really want to measure like how many of those happen in any given period of time, and then be able to drill into that sort of stuff. Figure out why was that runway crossing taking place, and what can we do to just mitigate those. Like usually what happens is that our taxiway Bravo down here may end up getting full, and so the air traffic controllers will have them line up on taxiway Charlie up here, which like it makes a lot of sense. But at the same time, when we have like super busy operations going on, that is not something that we want to do. Now the systems that we have, I won't name any of them because I don't want to shame them, definitely have the capability to do all of those things. But if we reached out to one of those commercial providers and told them, hey, we need your system to now tell us how many runway crossings were there in the last 12 hours or what have you, they would probably tell us, yes, we can do that for you, but it's going to cost you $150,000. And if you joined late, we work for the government, we do not have a big budget. We are not the Department of Defense. They do. That being said, we can then also, and this is again credit to Coco, very quickly do cool things like allowing people to mouse over this sort of stuff, and then you can see here we've got like the individual flights identified and even the hourly buckets when that stuff took place, which I think is super cool. I'll skip for a second. And so, if you can do it with runway crossings, obviously you can do it with all traffic that takes place at our airport here. And so this is, because everything is better in 3D, our heat map of the overall airport operations. Now the part that I'd like you all to focus in on is actually this little section. Well, I guess we can start back here. So here we can see a lot of aircraft are lining up for departure, so it makes sense that we have high bars and that they're red. It indicates that they've waited around there for a while. Everything makes sense. Our Chief Development Officer, Angela, coined this phrase, I think at least that she coined it, is an airport is just a construction site with a runway attached to it. And so what you see in this section here is actually the aftermath of, in this little L section here, is the aftermath of some of the construction that we did. So usually what's supposed to happen is that the aircraft will leave, like Terminal 1 here, actually it's down here, and then they will just move their way all the way this way. Now for a while there, we had this section of Taxiway Bravo under construction, and as a result they had to take this detour here, and you can still see those little bars that tell us that there were slowdowns happening in those sections. What made this partnership with Snowflake super useful is the construction managers, the operations people, everybody knew, yes, once the construction finishes, we will be able to move aircraft. Taxi hour time is going to decrease. What nobody really was able to tell anybody though is how much is it going to decrease by. Well, being able to look at this data, 23 seconds? Is that the number there? I think it was 23 seconds. And you may think to yourself okay, big whoop, you just decreased the taxi out time for your aircraft by 23 seconds, but then figure that we're departing about 325 aircraft per day, multiply that by 23 seconds, and you end up with a number that I think is somewhere close to, 2 hours. So, these kinds of, data efficiencies really start multiplying, and actually being able to tell somebody that you will get 2 hours of taxi out time back before the construction ever finishes. Well, I think that's what we're supposed to be doing as business intelligence people. And then this is where things just start going a little bit, to the steroid level. And actually, what I want to talk about here first before we get into the charts. So Daria mentioned that we started enriching this data with a lot of our own information. So the purple bars that you see there are what is actually supposed to have happened at our airport. So those are the scheduled number of operations in each one of those hourly blocks. And then you can see, obviously, that in this hourly block here, we ended up with more operations, which presents an opportunity for us because we will have private aviations, like maybe a private pilot does a touch and go or something along those lines, which are things that we have to accommodate. And I think my mic is about to go again. I'll just fix it myself. Oh, I'll just use it like this, or
this.
Oh, there we go. That's cool. Thank you.
Is it working?
It is working. Sort of. My voice is fine. I'll just shout it over to you.
No, you might need a mic.
They might need
The
it.
mic all the way back here.
Okay. I'll just do this then. No, that's fine. But so, this tells us like, the overage relative to, what we had planned. And then we were able to use Coco here in actually allowing us to say like, hey, for the airport operations, like duty managers, here are some facilitation requirements. So if you take some of these operations and assuming that you have, visual flight rules, and if you take 3 of these operations and you shifted them, say, into these hourly blocks, all of a sudden you will be able to fix the issue that you have in the 8 o'clock hour. So that was really, really neat for us as well. And then, further enriching this data, going, I'm kind of working backwards from that onion that I showed you earlier. And then we can also then apply this to the gates. So now I can hover over a particular gate here, and we can see the actual number of flight operations, the number of seats that departed on there, and the hourly EPAX profile relative to what the airlines shared with us there, which, now for the terminal operations coordinators becomes super useful information. And, let's just filter down on a particular gate. Let's go into our beautiful new terminal. If you have not flown out of New Terminal 1 in San Diego, I highly recommend it. It's a gorgeous facility. Oh, Snowflake. You can do it. Maybe not. So what you can see here while this loads is all of these blue and yellow bars relative to the gray bars that are sitting on the right-hand side effectively tell us what these scheduled operations that were supposed to happen in a particular gate were, and then what the actual number of operations at those gates. Oh, here we go. Now we have it limited down to gate 117. And so, now we can see, okay, we had this many capacity minutes. This was our actual utilization, our scheduled utilization. So we're somewhere above that. Why did this happen? And then, enriching this further, we can see the schedule and actual start, end, and so forth and so on. And again, it starts with the ADS-B data, which is just further contextualized with the other information that we're bringing in there. And then the last slide that I want to quickly talk about, and I made it until now before somebody walked out, which I'm actually going to say is probably a pretty good record for this conference, so that's kind of cool. All right, Daria mentioned, what was the solution that you mentioned for geospatial, for mapping?
The routing. Overture maps.
Okay, so what we also found is that there is OpenStreetMap. It's a beautiful collaborative community, and on there's this one user, Jason Bob. We're pretty sure that he works at the airport. He logged all of these footpaths into OpenStreetMaps. And previously, what we would do whenever we wanted to look at a particular concessionaire's performance, we would just say, take Terminal 2 East over here, and then just divide all the passenger volume that goes out of Terminal 2 East over here into the concession sales of Artisan Market. Full disclosure, I faked the numbers of Artisan Market up here because I didn't think they would appreciate me sharing the actual sales data. But what we were able to do now, having all of these newly found geospatial capabilities, is to very quickly pull in the OpenStreetMap path data that somebody provided there, so that's those black lines that you're seeing there, and then to work out from there, well, an average person walks, a certain speed, and so how far is an average person going to be able to walk in, 2 minutes, 5 minutes, 10 minutes, and so forth and so on, or 15 minutes. And so rather than taking that entire bucket of those terminal sales or terminal passengers to divide into the sales, we actually now only take, the passengers that 100% of the passengers that are within 5 minutes, 75% of the passengers that are within 10 minutes, 0% of the passengers that are within 15 minutes, because who here would walk 15 minutes for a particular concession sales location? You would? Maybe? Okay, if the food was really good. Maybe. Okay, that's pretty much all we got so far. But if any of you are working for an airport, an airline, or have anybody else that, that you can think of that might be interested in collaborating on data like this, please do reach out. Yeah. Thank you for attending Snow in San Diego.